So in this video, we're working with exponents. And we're going to start out with the example that you're looking at. We have a base, which is 3, and an exponent, which is 4. This tells us to multiply the base 3 to itself 4 times. 3 times 3 times 3 times 3. We could also use it as a variable. So we could have something like x to the third, which is the shorthand way of writing x times x times x. So now we're going to talk about rules of exponents. So we're going to look at the product rule. To multiply two exponential expressions that have the same base, you keep the base and add the exponents. So what does that mean? If I have x to the a times x to the b, that would give us x to the a plus b. You'd keep the base and add the exponents. Well, why would that be the case? Well, let's look at a specific example. So if we had x to the third times x to the fifth, if I wrote this out, what x to the third means, it's x multiplied by itself 3 times, and then x multiplied by itself 5 times. How many x's now are being multiplied to itself? 1, 2, 3, 4, 5, 6, 7, 8. 3 plus 5, or x to the 8th. So instead of having to write it all out and do that, we see that we would just say we have 3 x's being multiplied plus 5 more x being multiplied to give us 8 x's being multiplied to itself. So I could say y to the 8th times y squared. So that would give us y, and now there are 10 y's together. Again, the base doesn't change, just the exponent changes, and it changes to how many y's are being multiplied together. If I had z to the 12th times z to the 5th, I'd have 12 plus 5, or 17 z's being multiplied together. If I had negative 2 to the third power, we know that I could say that's negative 2 times negative 2 times negative 2, or we'd get a negative 8, correct? So we have to be careful. What if I had negative 2 squared times 2 to the third? Well, let's change this up. Let's say negative 2 to the third to 2 to the third. This does not equal negative 2 to the 6th or 2 to the 6th, because the base truly isn't equal. We know that negative 2 to the third would give us negative 8. We just saw that. And 2 to the third gives us 8. So our answer with negative 2 to the third times 2 to the third, it would be negative 8 times positive 8, or negative 64. Again, I can't combine the exponents just because the base almost looks the same, but this is a negative 2, which is very different than a positive 2. Things to think about. What if I had negative 2 to the third times negative 2 to the third? Then I could say that's negative 2 to the 6th. And since that's a positive exponent, so I'm taking a negative number multiplied by itself, an even number of times, it's going to give me an even number. And so this would be a positive 64. And I should say, because of this, it's not necessarily true that it could equal that. I'd have to figure it out this way. What if I had something like this? Well, like any multiplication, I multiply the numbers together. 3 times 2 gives me 6. And now I have x to the 4th times x to the 5th. Then that would be x to the 9th. Now what if I had, let's say, x to the 6th divided by x to the 4th? Let's look what happens. I have 6 x's on top, 4 x's on the bottom. And look, they cancel. The bottom cancels with the top if they're identical. 3, and now the 4th one. So when I take them away, I'm left with x squared. And we're going to learn that we can find this out because we literally are taking 4 from the 6 up top there. That this is really 6 minus 4. We could think of it that way, that we have the same base, so you would subtract the exponents because you truly are taking them away. So if I had x to the 5th over x to the 3rd, this is x to the 5 minus 3, or x squared again. So the quotient rule would look something like this. X to the m divided by x to the m equal x to the m minus n. So I could do a couple of examples. What if I had x to the 7th, x again to the 3rd? This would be x to the 7 minus 3, which is x to the 4th. What if I had something like x to the 12th divided by x to the 4th? Well, that's x to the 12 minus 4, or x to the 8th. You could also have something like this, y to the 3rd divided by y to the 7th. Now, if you don't want to see negative exponents, then you would look, and you'd look for which exponent is larger, and that's where the base would remain, and you do the subtraction in either the numerator or denominator. So in these cases, the numerator's number were greater, so we pulled everything up top. With this one, with 7 being larger than 3, we're going to pull this here. So it would look like this, y times y times y, and then there's 7 y's down here. So I'm going to take 3 of these, so I'm left with 1 on top, and y to the 4th on the bottom. In other words, since 7 was greater, I would have said y to the 7 minus 3, which gives us that y to the 4th in the denominator. Because remember, when we did this, and we had this was like saying there was a 1 in the denominator there, which we generally don't write. So here, that's why when we cancel out, we're left with 1 on the top and y to the 4th on the bottom. So if I had x to the 15th divided by x to the 20, I would say 1 over, because I'm taking 15 x's from the top, I'm canceling them out with the 15 x's on the bottom, and I'm left with x to the 20 minus 15, or 1 over x to the 5th power. And again, what if I had z to the 5th power over z to the 5th power? Well, I have the same thing on top as on the bottom. This equals 1, because z to the 5 minus 5 would give me z to the 0, which equals 1. So we find that any base whatsoever raised to the 0 power equals 1. So x to the 0 equals 1, no matter what x is. Now, if we have 0 to the 0 power, very strange. We know we can't have anything divided by 0 because that's undefined. So we know any number divided by 0 is undefined. Because we know how division works. If I have 3 times 2 equals 6, then 6 divided by 2 equals 3, because 3 times 2 equals 6. So if I had 6 divided by 0, what would we say here? What number times 0, what number times 0 would give me 6? There is no number times 0 that could give me 6. So therefore it's undefined. There is no number we could ever multiply by 0 to get anything other than 0. So keeping that in mind, let's look at how we would define 0 to the 0 power. We define it as undefined in here. If we look at 0 to the 0 power, it's undefined. Why? If I look at 0 to the 1 minus 1, that'd be like saying 0 over 0, which we know is undefined. So we just classify as 0 taken to the 0 power as undefined. Now what if I raise a base to an exponent and raise that to a power? That's like saying take x to the third, multiply by itself 4 times. 4 groups of x to the third, which would be 3 times 4, or x to the 12th. Because we could break those up, 3x's, 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 4 times, which would give us x to the 12th. So we have the power, if I have x to the a power, and we take that to the b power, that equals x to the a times b. So when we have something, a base, raised to a power, that being raised to a power, we multiply the exponents. If we have a base raised to a power times that same base raised to a power, we add the exponents. So if you had x to the, let's say 7th, to the 5th power, that would be x to the 35th power. Now if I had a base that looked like this, xy to the 3rd power, I could rewrite it as xy, 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 and we see that that's 3 x's and 3 y's all being multiplied together. But when we have a product raised to a power, we might want to rewrite it as x to the 3rd, y to the 3rd, where we can put each of the bases to the power it's being raised to. So if I had something like 2xy to the 3rd power, that would be 2 to the 3rd, x to the 3rd, y to the 3rd, or 8x cubed, y cubed. If I have a quotient, that would just be raising the x to the 3rd power, y to the 3rd power, because we know if we rewrote this out, it's x over y times x over y times x over y, which is 3 x's being multiplied together and 3 y's being multiplied together in the denominator. And so we'd have that. So now I can ask, hey, let's simplify. Let's do 4 over w to the 3rd power. This would be 4 times 4 times 4 over w cubed. And that would give me 64 over w cubed. So here's a synopsis or a summary of what we've done with exponents. If you have the same base raised to a power times that same base raised to a power, you would add the exponents. If you have a base raised to a power divided by that same base raised to a power, there's 2 cases. If the a is greater than b, if you have more x's on top than on bottom, then you keep everything on top and say a minus b. If you have more x's on the bottom, meaning b is greater than a, or another way to say it is a is less than b, then it would be 1 over b minus a, and the x's would remain on the bottom because you had more of them. And if a and b equal each other, then it's x to the 0, which equals, since they're both the same, which equals 1. This all is true if x just doesn't equal 0, because you can't have 0 in the denominator. Now, if you have a base raised to a power, and then you raise that whole thing to a power, that's when you multiply the exponents, because we'll have b groups of a, so b times a. If I have xy, or a product raised to a power, then I can put that power to each of the different numbers in that product. So this would be x to the a times y to the a. If I have a division, x over y to the a power, it'd be x to the a, y to the a in the denominator, if y doesn't equal 0. So write in simplest exponent form. Well, we have 1, 4. We have x's and y's. We have 1, 2, 3 x's and 1, 2, 3, 4 y's. That's written in the simplest exponent form. Now we want to leave answers in exponent form and do whatever we can to help simplify our expression. So base 4 is in both of these, and we add the exponent. 3 plus 5, so this would be 3 to the 8th would be my answer. 6 times negative 9. That gives me a negative 54. I have 2x's times 3x's. That would give me 5x's being multiplied all together. So my answer is negative 54x to the fifth. Now we have this where we have some fractions in here. So we'd multiply 2/5 times 1/3. Since nothing can cancel from numerator to denominator, I multiply 2 times 1, which gives me 2, and 5 times 3, which gives me 15. There are x's and y's, and now we have to see how many x's are being multiplied. 1x and then 2x's, that gives me a total of 3x's. 1 plus 2 gives me 3x's being multiplied. Y to the third, y squared. 3y's plus 2 more y's gives me 3 plus 2, or y to the fifth power. So now we look at this problem. I know 7 goes into 51 3 times. So we'd have a negative 3 in the numerator. Now we have 6 x's on top, 3 on the bottom. So we'd have x 6 minus 3, or x to the third on the top. And now both of these are the same, so they cancel each other out. 8 minus 8 would give me 0, so my answer would be negative 3, x to the third, and we don't see any y's because y to the 8th cancels with it and leaves me 1. Now we look at this, where we have 5x divided by 7y squared. Nothing can cancel inside of here. So now what we do is we're going to square the top and square the bottom. So I have 5 squared on top, x squared on top, 7 squared on bottom, and y squared being squared, basically like this. So I'd have 25x squared, 49y to the fourth. Now let's look at this last problem. Well, in here, I see that you want to clean up what you can inside of here. So I'm going to leave everything to the third and do cleanup. So 4 is going to remain on the numerator. I have 2 x's in the numerator, 1 x in the denominator. So that would leave me x to the 2 minus 1, or x on top. And I have y to the first in the numerator, y to the third in the denominator, bigger numbers here. So I'm going to have y to the 3 minus 1 in the denominator, or y squared. And I'm going to take that to the third power. So if I do that, I have 4 to the third, which is 64. And then I have my x, because that's an x cubed, and y squared to the third power, so y to the 2 times 3, or y to the 6th. And there's my answer. Now we're going to deal with negative exponents and give the definition of a negative exponent. So x to the minus n equal 1 over x to the n if x doesn't equal 0. So what a negative exponent tells us is if I'm in the numerator, I need to be in the denominator. If I'm in the denominator, I need to be in the numerator. So what do I mean by that? If I had x to the negative n over y to the negative m, we don't like to see negative exponents. So what this tells me is I'm unhappy here in the denominator. I want to be in the numerator. So we pull it up here to the numerator. And this is telling me I'm not happy in the numerator. I'd rather be in the denominator. So it basically tells us it's on the wrong side of the fraction. So if I have 2 to the minus x, I could rewrite that as 1 over 2 to the x power. If I had 2 to the minus 3 power, that's 1 over 2/3, or we know that's 1 over 8. That type of idea. So here are 2 examples. If I had this is telling me that x is unhappy in the numerator, y is unhappy in the numerator, and z is unhappy in the denominator. So my first step, what I would do is always get rid of the negative exponents. So I have z to the 4th, x squared, y squared. And now looking at it, there's no more simplification in there. I'm going to show you 2 ways to do this problem. The way I generally do it is I try to get rid of the exponents, the negative exponents inside the parenthesis first. So I would rewrite this as 3 is okay, x is unhappy in the numerator, wants to be down here, y is unhappy y is happy because it's got a positive exponent. That's raised to the -3. Then I would say, since this whole thing is to the -3, this tells me that everybody inside is unhappy where they are. So the x to the 4th comes to the numerator, and the 3y squared goes to the denominator, and now I can cube it. So I'd have x to the 12th, 3 to the 3rd, y to the 3 times 2 is 6. So my answer would be x to the 12th, 27, y to the 6th. Another way someone could do this is they'd take the problem, they'd start out with the 3, x to the -4, y squared to the -3 power. And then they'd put the exponent through in here. So this is like 3 to the 1st power, so you'd have 3 to the -3, 1 minus 3 is that. X to the -4 times -3, which is positive 12, and y to the 2 times -3 is -6. So this tells me I'm on the wrong side of the fraction. 3 to the -3, it wants to be in the denominator as 3 to the 3rd. Y to the 6th then wants to also go to the denominator, and x to the 12th remains on top. And once again, I'm left with x to the 12th over 27 y to the 6th. So there's many different ways you can go about doing this problem. Many different ways. You pick your pattern and your technique to do it to make sure you get your so you get non-negative, or rather I should say positive exponents, and written in the right place, whether it should be in the numerator or denominator based on your problem. So we could have a problem that would look like this. So looking at this one, I could initially flip everything inside there to get rid of the negative exponent and make this y to the 4th divided by 4x to the -2, y to the -2 squared. Then I could go inside and work on it. Now generally, I like to work on the inside first and then get to the exponents, but this would be fine if you wanted to do it this way. Now I'm going to rearrange and get rid of negative exponents inside of here. So 4 remains on the bottom, but the x squared, y to the 3rd, want to go up top, and again we're squaring this. Add things that are alike, so I have y to the 7th, and I like to do it in alphabetical order, x squared divided by 4. Squaring this, so my answer would be x to the 4th, y to the 14th, divided by 16. And I'd have my answer. So that's a look at exponents. Thanks so much for watching.